Okay, my friends, so let's do a couple of these conversions between kilograms and pounds. So the first one we've got is, we got a 200-pound person. We don't know how many kilograms they weigh. Okay, so the first thing you have to do is you have to look up the unit fraction that compares pounds to kilograms. And there's a couple of them that you can use. Depending on when you Google them, you can Google either how many pounds are in a kilogram, where you'll discover it's 2.2 pounds in 1 kilogram, or how many kilograms are in a pound, and it ends up being about, I think it's 0.454 kilograms in a pound. And the numbers don't make any sense because one of them is metric, which does make sense, and one of them is imperial, which doesn't make sense. So we're stuck with this. The reason dimensional analysis exists in large part is because you've got the metric system, which makes sense, and the imperial system that doesn't, and you have to be able to go between them. Because some countries, like the United States, are too hard-headed just to go metric. Anyway, rant over. So this first one, we got a 200-pound person. So we have a 200-pound person. Okay. I'm going to put that over 1, like I did in the initial video there. We need to know how much this person weighs in kilograms. So the unit we need over here is kilograms. Kilograms. I'll shorten that eventually to kg. Okay. So we need the conversion in between them, right? There's going to be some kind of a conversion here. And that conversion is going to be a unit fraction, just like we were studying in the last set of notes. And we're going to use multiplication of fractions to do that. So we're going to multiply by the unit fraction that will get rid of the pound unit and replace it with the kilogram unit. Now, thinking mathematically and thinking about fractions, if pounds are up here in the numerator, that tells us pounds have to be down here in the denominator. And that means that kilograms has to be up in the numerator. So now, eventually, what I'm going to do is grab a different color of chalk and cancel off the pounds. It's kind of one of my favorite things to do. But what we have to do is we have to have the correct unit fraction that goes here. Now, because of what I just said, there are 2.2 pounds in 1 kilogram, or there are 0.454 kilograms in 1 pound. You've got 2 different kinds of unit fractions you could use here. One of them is you could use 1 kilogram is 2.2 pounds. I'll make that plural because I'm feeling better. And we'll do this one first. And then we'll go back and show you how to do it with the other one, which is the 454 kilograms is 1 pound. We'll do this one first, though. Okay, so that's not the right color. Let's use a different color. Let's use, fuchsia. So the reason I'm grabbing this is pounds are gone. You got pounds on the top, pounds on the bottom. They divide off, leave 1 behind. So now what you got is you've got 200 divided by 1, which is just 200, times 1 kilogram over 2.2. And now we're almost kind of back to just unit fractions. All we got to do is deal with this. So once again, this is just a number, 200 over 1. This is a fraction that has a unit in it, which means we can break out the numbers and the unit. So this is going to be 200 over 1 times 1 over 2.2. And the final unit that this thing is going to have on it is going to be kilograms. So all we got to do now is do the math. 200 times 1 is 200. 1 divided by 1 times 2.2 is 2.2. What is 200 divided by 2.2? My dear friends, that's about 90.9. I'm going to call that 91 kilograms, because I think that's what the nurses tell me to round off to, the nearest kilogram. You can round off to whatever you want. 91 kilograms. All right. So, if somebody's 200 pounds, they're 91 kilograms. Boom. Now, I mentioned earlier that the unit fraction I chose to use here had the 1 with the kilogram and the 2.2 with the pounds, because there are 2.2 pounds in 1 kilogram. Well, how many kilograms are in 1 pound? Depending on what you Google, you're going to get one of either of those. Let me reset the board back to kind of the beginning, but not exactly the beginning. That'll never get old to me. I apologize in advance. I'm probably going to do it every series of notes. Okay, so here, this is why I said back to the beginning, but not all the way back to the beginning. We still have a 200-pound person. We still need their weight in kilograms, and we still know that the units have to be that way to make it work. Oh, I should probably cross off the pounds. But now the question is, in the last one, we had 1 kilogram, 2.2 pounds. What if we had 1 pound? Well, if you Google how many kilograms are in a pound, you're going to see it's 0.454. Now, mathematically, this is going to play out the exact same way. It's just that the numbers in that conversion unit fraction are going to be in a little bit different place. This is going to be 200 over 1 times this is going to be 0.454 over 1. And the unit is still going to be kilograms. That hasn't changed. So unit-wise, the spelling hasn't gotten any better, though. Unit-wise, we still are going to have kilograms or kilogrammas. But mathematically, now, we don't have to divide by 2.2. We're going to multiply by 0.454. So all we got to do is do 200 times 0.454. 200 times 0.454. And I get 90.8, which once again rounds to 91 kilograms. And of course, it needs to be the same thing. I'm going to try to not spell anymore and just call it kg for kilograms. It has to be the same because the unit fractions of 0.454 kilograms per 1 pound is equivalent to 1 kilogram is 2.2 pounds. If you divide 1 by 2.2, you will get 0.454. Well, you get 0.4535, whatever that number, but it rounds off to 0.454. Okay, friends, quick little interruption here, and it's more about just the annoyance of the numbers we're using. I keep using 0.454 kilograms in a pound, which is correct, that you rounded to 3 decimals. However, if you actually divide 1 by 2.2, like I just said, it actually rounds to 0.455. And that's because there aren't exactly 2.2 pounds in a kilogram. It's like 2.205. So just, again, it's me just expressing consternation at the lack of our country's use of the metric system. Anyway, back to the good stuff. Okay, so that's how we change a pound, a person measured in pounds to kilograms. Let's use the same skill set to go the other way. All right, this one we've got somebody in kilograms. They're 85 kilograms, kgs. 85 kilograms, we have them in kilograms. We need them in pounds. Okay. So again, I'm taking the liberty of putting both of those things, what's that noise? Putting both of those things over 1, okay? We need a conversion fraction here. And that's gonna, and hopefully now we can also see what units need to be where. Kilograms is up here, and we need to get rid of kilograms, which means it has to be down here. Pounds is up top, which means we gotta put pounds up top here to maintain it. Now the question is, what goes where? Well, it doesn't matter. You could either put 2.2 pounds per 1 kilogram. Or you can put 1 pound is 0.454 kilograms. Either, mathematically, they're the same thing. 1 divided by 0.454 is 2.2. I think most students are going to like this way better because of 2 things. First of all, the units get taken care of. But also, the math on this way is very, very simple, right? You got 85 times 2.2 and then 1 times 1. Pounds. So 85 times 2.2. 85 times 2.2. I get this person weighs 187 pounds. 187 pounds, about. Well, actually, that's, if I use 2.2, it's exactly 187 pounds. but I'm not even sure that 2.2 is exact. I think that's rounded off too. I'm not going to complain about the metric system and the imperial system anymore. 187 pounds. Now, if you chose to go the other way, and I'm going to show you this, I'm not going to do them both ways each time. I'm just, for this first example, just to show you that you can do it both ways, you would have 1 pound up here and 0.454 kilograms in the bottom. Okay, units is still going to be the same. The only difference is you're going to have the 1 here and the 0.454 down there. I can hear you screaming from here. People hate this. They hate doing the division by a decimal. But check it out. 85 divided by 0.454 ends up being 187.22 pounds, which again is 187 pounds. It's just not quite as exact this time because that decimal, well, it's a little bit uglier. Okay, so the connection between all of this is the unit fraction that's right here. And any conversion fraction that's a unit fraction is going to have at least 2 variants, because the 1 can be with the 1 unit, or the 1 can be with the other unit. Your choice. And that's what's kind of cool about them. You get to choose. And as you do more and more of these, hopefully you'll see which one makes the most sense in what situation. Speaking of which, let's try some more.